Hi, sixth graders. We're on lesson 1010, which is reflections. Our learning target is being able to identify figures with lines of symmetry and graph reflections of figures on a coordinate plane. So line of symmetry is one vocab word that you want to write down in your notebook. Is where you can fold the image and have both halves match exactly. So if we look at this figure right here, we can see if we draw a line right down the middle, we can flip it in half, and each side would go, basically what you want to see is if it would go exactly on top of the other side, and then you know it's a line of symmetry. This figure right here has more than one line of symmetry because we can fold it down each of these lines and still it would be folded on top of each other. And E, we can see, has a line of symmetry horizontally down the middle. If we do one down the middle here, and then we fold it on that, we can see that it obviously would not be the same. This does not have a line of symmetry at all. And then an H has two lines of symmetry, a vertical and a horizontal right down the middle. So a reflection, which is another word that you should write in your notebook, is the mirror image of a figure. So basically, when we are drawing a line of symmetry, back to here, drawing a line of symmetry, this side is basically the reflection of this side over here. Just like the E, this side is reflecting over this line to get this image over here because it's exactly the same on both sides from the line of symmetry. We can see this long line for our E, the long horizontal line, is the farthest away from both sides of the line of symmetry. So a reflection is a mirror image of a figure. So you think of when you look in a mirror and you see exactly yourself and everything else that's in the mirror reflected. If you're standing really close to the mirror, then your image is close in the mirror. And if you're standing far away, then your image is really far away. So you can think of the X and Y axis as the mirror, and you're reflecting over either the X or the Y. So if we look at A, and we want to reflect over the x-axis, so this is x. If we want to reflect A over the x-axis, this point needs to be the same exact distance away from x on this side as it is on the other side. So we can see that we can go 1, 2, 3 steps to get to x. So that means we have to be 3 steps away from x on the other side. 1, 2, 3. And our point is right here. And then we would call that A prime. So I'm going to label it A prime. And we can see we go over to the left 2, so -2. And then -3. If we reflect it over the y-axis, so now we go towards our y line, so 1, 2, and then 1, 2, 2 more over. So here's A prime, but it's reflected over the y-axis. So this one is 2, so over 2, up 3. So we can see our numbers are the same, our signs are different. So let's check out B. So if we look at B, which is 4, -1, if we reflect it over the x-axis, that means we're going over the x-axis. It's 1 away here, so it's going to be 1 away there. We're on the other side of x. So I know that I go over 4, up 1. So B prime, B reflected over x-axis is B prime, and it's 4, 1. And then if I go over the y-axis, I have to go 1, 2, 3, 4. And I count the axis, so it takes me 4 steps to get there. So I go 1, 2, 3, 4 more to get there. and we have -4, -1. So B prime over x-axis, B prime over y-axis. So if we look at this, we start with -2, 3. Over the x-axis, our x stays the same, our y value changes. Over the y-axis, our x value changes, our y value stays the same. Let's see if it's the same over here. 4, -1 over the x-axis, 4 stays the same, y value changes, -4, so x value changes over the y-axis and our y value changes. So reflecting over the x-axis, we change the y value. Reflecting over the y-axis, we change the x value. Something that you want to write down. You did not need to write this whole graph down, but you should write this down right here. So now when we have a triangle and we want to reflect over the x-axis or the y-axis, but we're going to talk about x-axis first, when we have a figure, in this case a triangle, we have to reflect each point over the x-axis and then we can draw our reflection triangle. So we're told that ABC has vertices A, B, and C, which is 5, 2, 1, 3, and -1, 1. So we can see that here's A, B, and C. When we reflect it over the x-axis, we have to make sure that each point is the same distance away. This is 1 spot away from x, so it's 1 more spot on the other side. 2 and 2, and then we look at B, 1, 2, 3, and then 1, 2, 3. So we can write the points, and we can see. So A was 5, 2, reflecting it over the x-axis, 5, -2. 1, 3 for B, and then we have 1, -3, and then there's C. So this right here is something that you want to write down for sure. When we reflect over the x-axis, we need to keep x the same and then take the opposite of the y value. So if it's positive, we make it negative. If it's negative, we make it positive. We need to do this for each point in our figure. So because we have a triangle, we have 3 points, so we need to do it 3 times. And then we label, remember there's that little apostrophe, which means A prime, B prime, C prime, so that's the reflection. If we are reflecting over the y-axis, for this example, we have a quadrilateral, which is K, L, M, N, and here's the vertices, and we're going to graph it over the y-axis. So this time, we're going this way over to, we're starting with the blue and we're going over to the green. So we're counting to make sure it's the same distance away from y. So if you're given a figure and you graph the points and then you graph the image, you always want to look and make sure that after you've graphed them that they're exactly the same distance away. So we can see K is 2 on each side, L is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 on each side, N is 1 on each side, M is 1, 2, 3, 4, 1, 2, 3, 4, 4 away on each side. So then we can look at our new points, and we know we started with K at 2, 3. We reflected it over the y-axis, and we end up with -2, 3. L is 5, 1. We reflect it over the y-axis, and we end up with -5, 1. And you can see our y, we're not going up or down at all. When we're reflecting over the y-axis, we're just going to the left or to the right. So that is why when we reflect over the y-axis, something else that you want to write down, you first take the opposite value of the x value, and then you keep y the same. So m, 4, -2, we would change 4 to -4 and keep y at -2. N, we have our first point in our figure is 1, -1, which is right here. Take the opposite of our x value, which is -1, keep y the same, which is -1, and then once you have all of your points for your image, then you graph that. So just a reminder, when we're reflecting over x, we keep x the same. See how we kept x the same, and then we changed y to negative, or if it's negative, change it to positive. Keep x the same, change y, keep x the same, and then change y. Old original points, new points. Original points right here, new points right here. Okay? There's a couple more examples in your book, so you can log on to, or open your book, or you can log on to the online textbook. Otherwise, log into NICU and take your 10-10 quiz, and have a good night.